So maybe we can get started, and I know folks will probably join a little late, but that's fine. So we can get started.
Okay. Thank you. بسم الله الرحمن الرحيم والصلاة والسلام على سيدنا محمد وعلى آله وصحبه أجمعين. Dear Dr. Eldus, dear Dr. Muhammad, distinguished participant, it's my pleasure to welcome all of you and to thank you to join us today in the first EI group events. I am pleasure to be the moderator of this inaugural session of the activities of artificial intelligence group. I think which was established in the last March as a group of Maqasid Institute to be pioneer in the research and the study of artificial intelligence according to the theory of Maqasid and all Maqasid perspective. This group, I think, the group of is a group of scholars and researchers who have experience in the field of Islamic studies, humanities, and technology, belong to this research group, including our lecturer today, Dr. Muhammad, is a member of our group. So I think the best way to start the group activities is a topic related to the Holy Quran. I think that's why our topic today, it's exactly Quran computing and AI deep learning algorithm in Matlab. Right. So please, first of all, let me give a brief introduction about distinguished lecturer, Dr. Muhammad. Yes, Dr. Muhammad Khair is a medical device engineer and director with a Bachelor and a Master of Science in Biomedical Engineering from Marquette University and an executive MBA from University of Illinois, Urban Champion, yes, in 2007. Also participated in graduate studies towards a PhD ABD in electronical engineering at Illinois Institute of Technology. And also Dr. Muhammad research interests are in the medical device technologies and algorithm for novel and reliable electronic healthcare. Also, Dr. Muhammad interests include development of Quran analytic database and application that are enabling for discovering of numeric structure reflecting the precision within the Quran verses. Also building database that enable development of participation in artificial intelligence and Arabic natural language processing application for automating users' ability for Quran recitation and memorizing. Dr. Muhammad has over than 45 patents and patents applications and 5 scientific journal applications. So we are very pleased to host you, Dr. Muhammad. And I think Dr. Muhammad is our member, so it's not a host. So now I refer the floor to Dr. Muhammad in order to present his intervention within, I think, 45 minutes. And then we will open the way to answer and to the question and discuss the questions.
Inshallah.
Please, Dr. Muhammad.
Thank you very much.
If you have any question, please, all of you, can you write it in the chat box? Thank you, Dr. Muhammad. Yes,
thank you. Appreciate it. Thanks for the introduction, and it is my pleasure and honor to be with this group, working towards a better understanding of the Quran and to digitize and modernize our tools so that we can perform research and develop our understanding of the Quran in a better way, inshallah. So I really appreciate your participation in this lecture. I will try to limit myself to 45, so I'm going to go a little bit fast But please stop me if I lose you, or if you have questions. Please feel free to stop me, and I'll maybe pause between sections of the presentations to address any questions.
Yeah.
This lecture is being recorded, just so everybody knows, and I'm going to share my screen in a second. Okay. Bismillah ar-Rahman ar-Rahim. So I'm Muhammad Khair from the Quran Computing Institute, and I have been working also with the Maqasid Institute team as well on with the AI team. So my work is related, and lecture today is related to Quran computing and AI deep learning tools. Since this was introduced already, I'm going to skip over it. But I do live in the US, and I'm originally from Jordan, for those who don't know. I'm going to cover today development of Quran statistics Excel tables, development of the Ar-Raqim Quran search, which is a desktop program, Windows desktop program, AI deep learning applications, and the tools used to develop that with Matlab. And also a proposed platform development steps for Maqasid research. This is hopefully kind of at the end. I would love to leave you with some thoughts on the Maqasid platform development as well, which is more relevant to the work that you guys are doing. This lecture is going to be in English, but I have a lot of slides in Arabic. I have been presenting at Arabic conferences, and so kind of challenging myself to, as a native, well, I've been in the US for 35 years, so trying to challenge myself to do presentations in Arabic. Most of my slides are in Arabic, however, I'm fluent in English, so I will translate on the fly, if you don't mind. So there's going to be some mix of slides in English and Arabic, but I will cover the Arabic slides in English as well. So please maybe just focus on the points that I will translate versus if you don't know Arabic, but hopefully a lot of you do know some Arabic as well. So these are the areas of research that I have been developing. Essentially, I started initially doing statistics, kind of primary statistics on the Quran, or elementary statistics, just essentially developing programs to quantify in every surah, every verse, every word, every letter, their position in the Quran. And according to multiple systems of counting, there are obviously we talk about this is Hafs an Asim, Qira'at Hafs an Asim, and we do realize that it's the same words. There are some 37 words that are compound in their nature, and there's some kind of opinions about whether a space should be placed between the kind of parts of a compound word. Those are only 37 words, but it doesn't change the meaning or the pronunciation or anything like that. So from that, there are three systems of counting. One is mine that I came up with, Ihsa Khair, and there is Ihsa Noon, which is Markaz Noon in Ramallah from Sheikh Bassam Jarrar, and Ihsa Al-Kahil, which follows the Mus'haf al-Madina. And so so I've developed these statistics. There are also secondary statistics then that we can develop, which are around the connections or linkages between repeated words and repeated verses, as well as words that kind of occur together frequently, the frequency of recurrence. So I've developed these, and then also from those I developed memory maps for memorization of the Quran, as there are some linkages, and we'll cover some of that. I have many tables. Many of these will have links, URL links available for you to download at will. That are specialized tables. Some of them cover specifically Nurani letters. And from all of this primary foundational layers of statistics, and we're gonna move into AI research. The Raqim Quran search is an SQL-based Quran search program, Windows desktop, that essentially exercises SQL queries in the background, transparent to the user. The user doesn't need to know about SQL, but it just searches through all this database to provide you information about the data. So I essentially started with developing data, developing my statistics in Excel tables. Well, certainly they are these Excel tables are exported from an Access database. So when I populate, do my programming to do language processing or word processing of the Arabic Quran text, essentially dealing with all the Unicode structure of the letters and the formats of the letters, etc. My programs populate a Access database, and from this Access database, I export tables, several types of tables, based on the need of what we need to develop. So, most of these tables, or all of these tables, are available on this Facebook page, but also there is a research science paper that I published on this that's available at the link below. The Quran, of course, it has linguistic structure and precision to it, and that is miraculous. But most of us really need to understand Arabic to appreciate that linguistic majesty of the Quran and its style of expression. The linguistic aspects of the Quran are also associated with numeric precision and numeric kind of every letter, every word is positioned in the Quran is placed with absolute precision that when you interpret the text in a numeric fashion, you find a lot of relationships that are just majestic and miraculous. And that's part of what these tables reveal to us, or help us understand those tables. Help us understand the text in a numeric perspective. The Quran, if you remove repeated words, there are 19,209 words. So the Quran itself is about 77,407 words. But if you remove repeated words or recurrences of words, it's 19,209 unique words with tashkil. But if you look at the roots of these words, how many these words were, some of them are derivatives of the same roots. So by looking at it from a root perspective, there's only 1,756 words that have roots. There are a few words without roots, and like pronouns, etc. But so if you want to count those, maybe you'll get maximum 2,000. So that's, if you really want to understand the Quran from a terminology, vocabulary perspective, focus on these 2,000 words, right? And then you'll understand the derivatives of them, which is 19,000, and from the recurrence of those, you'll understand the 77,407 words. This is a kind of a list. I'm not going to go through all of this because we don't have a lot of time, but a list of all the statistics, the preliminary statistics that were included in my tables. many of them analyze the Quran from front to back and back to front, and in terms of across the entire Quran, within the surah, within the verse, and word by word analysis, letter by letter analysis. So really, those are, and then looking at the recurrences and number of recurrences, etc. I've done some research also on Asma'ullah al-Husna, the names of holy names of Allah, subhanahu wa ta'ala. And those are essentially trying to create a more complete table, if you will. This is those were the words table. This is also letters tables, and those tables include also similar statistics from front to back, and recurrences and number of letters, etc. Many aspects of preliminary statistics, I call them, or first order statistics, if you will, because we're going to go into second order statistics in a bit. These are links and URLs for all these tables. You can download them and use them in your research. There's also some more tables about specifically that are, I call these specialized tables. For example, which are the words that were started with in each verse or ended with in each verse. Within the scope of a surah or within the scope of the entire Quran. Also, what are the ending letters and in each surah, or ending two letters in each surah, in the scope of a surah and in the scope of the entire Quran. I looked for also which verses there is, where the Quran uses a lot of recurrence of or repeats some verses. The most repeated verse is فَبِأَيِّ آلَاءِ رَبِّكُمَا تُكَذِّبَانِ, was repeated 31 times. In Arabic language and culture, when we repeat words we try to emphasize. It's repeated for emphasis and for underlining, underlining the purpose of that verse, essentially. So you can look at it from that perspective. From the entire Quran, there is 276 verses that were repeated from a 96 verse, original verse. So, and the rest are all unique verses. So you can look at verses that were repeated with specifically word for word, an exact word, or repeated by the roots of words. Right? So there may be like one or two letters differences, but between those verses, but there are some verses that were repeated by roots. See if I have it. Like this is, for example, a table. You can see, for example, اذهب إلى فرعون إنه طغى. اذهبا إلى فرعون إنه طغى. So it's only one letter difference, but it's the same roots of the words. إلا عباد الله المخلصين إلا عبادك منهم المخلصين. So there are some verses like this where you can only one or two letter differences, and there are some so they only repeat by the roots, looking at them from a root perspective versus exact syntax of the word. So also there are words that were repeated in adjacent locations, either twice or three times or four times. For example, words that are, for example, الذين إذا أصابتهم مصيبة. So أصابتهم مصيبة are both come from the same root, but they are different, they're derived forms of that root. تزر وازرة وزر أخرى. We say is three words, three repetitions from the same root. Or حييتم بتحية فحيوا. Those are 3 words also adjacent. And then there are 4 words, subhanallah, you know, الخبيثات للخبيثين والخبيثون للخبيثات والطيبات للطيبين والطيبون للطيبات. Those are 4 words from the same root that are adjacent to each other. And that's kind of the linguistic majesty of the Quran and miraculous form of it. So we've developed tables to express specifically the repeated words in exact form of the word, as well as in its root form. And the scope being repeated within the scope of a verse, or repeated within the scope of a surah, or across the entire Quran. And there are all these tables available. There are tables also specific to letters. You know, I should mention that. So these specific links are for tables in the khair system of counting, as well as the noon system of counting. And there are, you know, published papers for or books for kind of detailing the exact nature of each counting system. We should know that all systems of counting, whether it's khair, noon, or al-kahil system of counting, when you remove the hamza, we all have the same numbers of letters, which is 322,604 letters. Okay, in the early Quran manuscripts at the Prophet time, the hamza was not a letter that was written down. It became a harf tashkil, or a kind of like a fatha, kasra, you know, it's kind of like a tashkil to facilitate pronunciation. So was added later on as like a circle, for example, above or next to the letter or underneath the letter. You can find that in Andalusi manuscripts. But then later on in modern Arabic, it became a kind of a letter, because it was essential for people to figure out how to pronounce. But the Quraysh people back then, the Arab at the Prophet time, sallallahu alaihi wasallam, they did not need the hamza to be part of the. So the Arabic letters were 28, and today, if you include the hamza, they become 29 letters. Right? So, but 322,604 letter is the number of letters in the first script during the Prophet time, sallallahu alaihi wasallam. So these are tables for all these, letter by letter. Any questions so far that we can address? All right.
Yes, for statistic of letters.
Yes.
I saw that there is a difference between khair ihsa.
Yes, it's in the
yes. Then
right.
in modern.
Right, it's all hamza related.
The modern without hamza. With
it's hamza. All hamza related. Yeah, hamza is the problem of our modern world.
Problem. Yeah.
Okay, if you remove the hamza, we are in full agreement.
Yeah.
But the tashkil.
The tashkil, no tashkil there.
Yeah, the hamza was, again, it's kind of added depending on the script and that was used and how it was placed, etc., above the letter, next to it, etc. It's problematic. So we need some clear standards that how we treat the hamza. And it is that one letter that was not in the script during the Prophet time, and as we humans added it later on, we have disagreement on that one letter. You know, so yeah. But I
think riwayah like Warsh, you can help you, like, because the riwayah like Warsh, there is no hamza there.
Yeah. So we need to essentially develop these standards on how we treat the Quran text and how do we treat the hamza specifically. You know, yeah.
Thank you.
Sure, you're welcome. All right. So I will talk a little bit about the Quran, the Raqim program that I've developed to facilitate search through all these tables that I've presented. So we needed some program that helps the users browse through these tables at ease and without the programming complexity, right? So we needed to have a user interface that essentially is easy or simple to use for search purposes, that builds behind the scenes the SQL queries needed to search through the tables, database tables. This program is available freely to download here at the link at the bottom. And there is about an hour training, user training video in Arabic as well as in English. Links available to as well. I'm going to this is the program. I'll show you an actual use case for it. So, for example, here, if I search for the word Muhammad, for example, and I get 4 verses, right? Here you see that you can search. You can select which fields you're interested in. In this case, I've selected all the fields, but I don't need to necessarily. I can limit it to those 4, for example, this like that, and then I want the word and the verse group. And then I say, okay, I want the word Muhammad, and I get only these verses and words, right? So you can sub-select which amount or volume of information you want. You don't need, if you don't want some fields, you don't need to, worry about them. But then there are 5 levels of search, or you can compound your query in about five levels, right? With either and or conditions. So you can have a multiple levels. I want this word, and I want only in the Surah 16, for example, or Surah, Okay, so if I limit the scope to a particular verse, Surah 47, for example, right? So you can do searches like that by specifically querying. You can order the results ascending, descending. You can export the results to an Excel table. So right away, here's the verse that the data. So any results that is available, you can export right away. So you can continue your kind of research in Excel after you've selected the source data. You can also browse verse by verse or surah by surah. There's surah by surah. So for example, I can add next surah statistics around each surah, or a group of surahs, a range of surahs. Similarly, ayah by ayah, or a range of verses. You can choose from 2, or just browse one by one. Word by word, letter by letter, with modern script with the Hamza, or first script. Letter by, this is word letters. So it expresses kind of the words and their letters, which letters occurred in which words. And letter by letter in first script without the Hamza. I can like Bismillah ar-Rahman ar-Rahim. So there is Bismi Allahi, etc. ar-Rahman ar-Rahim, letter by letter, or with the Hamza, modern script, I call it, right? And then there are search tools that help you. This is statistics about which letters in which surahs occurred. So you can choose each range of surahs and how many letters, and this column is specifically for the Hamza. And then I give you the total with the Hamza and total without the Hamza on the side here. And you can choose which system of counting you want, Noon, Khair, or Al-Kahil, for example. There are some general calculators I've provided, which, for example, you give the surah, ayah, word, or letter in a specific order to that. And then, for example, if I want surah 2 al-Baqarah, ayah 100, for example, word 1, letter 1 of it, and that will give you at the Quran order, what letter that was, or what word that was, what verse that was, okay, across the entire Quran. So you can move from specific order to generalized order that way. It's a calculator. Specific within the surah, ayah, word, or letter, and then to Quran order of that ayah, word, or letter. But then also there are these reverse, where you give the Quran order of an ayah, it gives you the specific which surah or ayah, and which you give the Quran order of that word, it gives you that word, right? So ayah 30 is this, ayah word 31 is dhalika from this verse, etc. And then there is also for the letters. So those are forward and backward kind of specific to generalized order kind of statistics and calculators. And these calculators will differ based on which system of counting you're using. So they are essentially used for that purpose. All right, so this is generally a live demo of the program. So I'm going to skip over some slides. That just gives you that. Also, one of the important aspects of the Ar-Raqim program is to ability to translate between Arabic and English. So every field that you see here, all these fields on the user interface can be switched to English by a simple flagging of this button between English and Arabic. And that includes for all of these fields. So so you can do Arabic or English. So all of these tabs have Arabic English translations to it. So you can use the program in either modes. Thank you. So I want to share with you a little bit about the Ar-Raqim program as the background of the programming environment in Labview. So the reason I chose Labview is because of the ease of use in terms of how you put together user interface. So as you can see, all these choices, drop lists, etc., fields, programming in both Arabic or English, and Arabic as a Unicode, import and export into Excel, features such as these tabs and SQL, enabling SQL search, all that is done with the Labview development environment. And certainly that has to be enabled with algorithms. So if I look at the background, Labview, Labview is a graphical programming environment. Most tools that you're aware of, like C, C#, Java, Python, and Matlab, are all textual in their form. In the sense you have to write out the program that you need to develop. Well, Labview is a graphical development environment, so it differs by how we describe the logic, the control logic for programming. So for example, this is true, false. This is like a case statement where you can execute different conditions, like an if statement, essentially. This is a frame where you can control a sequence of logical steps. This here is a loop, a for loop, where you can, loop, and we have here two nested loops, for example, for controlling logic, things of that nature. So, so you can program using different data types. So if I share with you a little bit of, let's start a fresh page just to show you and orient you. You can start by either on the diagram, it's like two faces to the same token. Either the diagram where you add the programmatic things such as structures, for loops, while loops, case structures, event sequences if you have events from user interface, things of that nature. So you can, here's a for loop, for example, right? And here you can add also user interface components, the other face of the token is user interface. So I can add a numeric control or a numeric indicator, like for example, here's a indicator, a slider, you know. You can add tables, more complex things like tables, arrays. Here's some tables and trees, like this tree. You can add string fields, different tabs and splitters, etc. All kinds of nice user interface, including graphs as well. So, and the key thing is that we can, you know, kind of like control. We can express these. So, for example, let's add here's a plus minus, some mathematical operations. Let's say we can add this plus sign and connect it with the loop, and then display the result to here. So I want the slider to be an indicator in this case. So I'm just showing you quickly to, so for example, let's start from 5, and I want to loop for example, 5 times, okay? And when you run it, we looped 5 times. This is, I can say, where's my digital? It's 9, 5, 5, 6, 7, 8, 9. So that's 5 iterations that gave me the result. So that's how you program in Labview. And again, you can get more complex with all these features and tool sets. So just to give you kind of, but it's very fast because I only had to describe this with a mouse. So I didn't type a single word in here, right? So, so that's Labview development environment. All right. Any questions so far on the program? Are we good? You're welcome to download it, and I invite you to download it and also exercise review the training. So we talked about first order statistics and data, and that's kind of foundational. Like that's a foundational layer that we want to build upon higher order relationships and search engines, etc. So so now, what if I said, if I don't want to search word by word, I want to search for 2 words that are connected, right? A lot of times, these 2 words may be related by meaning. They may be related by recurrence of how many times they're mentioned together, tied together. For example, we say يعملون الصالحات, right? So you can search for يعملون and you search for صالحات, and you'll get 2 different results. And then the exercise of linking them together, the verses that are both يعملون الصالحات, requires a bit more maybe contextual analysis, if you will, to figure out the connectiveness of these words together. And so what I wanted to do is I wanted to see which words were mentioned more frequently, connected together, and that are adjacent to each other, or maybe like it's directly adjacent, or maybe 1 word apart only. So only 1 word, maybe like a negation word, for example, illa, or for example, أو nafi, harf nafi, right, or harf jar, or whatever, between those 2 words. So we wanted to, so I did the search in, for example, okay, how many, السميع البصير. You know, when you do search for 2 words, a lot of times you can have a more specific search query. So for example, you provide a verb and a subject, or a verb and an adjective, for example, right? Or or two adjectives together, or right. So you can do a bit more sophisticated search that way. But you have to have this data that's built already, database that's built around this, and then to query that database. So it gives you a bit more, when you have search using two words, it gives you more in-depth meaning, and the search query becomes more meaningful that way, right? So I did develop a database for the entire Quran, all the words in the Quran, their connectiveness, using the roots of these words. Okay, and I developed this table, which the link is available down below here. I call this second-order relationships. This is an example of the table. I will show it to you live since we can do that. Okay. So, for example, I come to these words. For example, I was searching for the word as ashab, and ashab comes with many connected words: ashab al-nar, ashab al-jannah, ashab al-jahim, ashab al-sabt, ashab al-yamin, ashab al-shimal. Right. So all kinds of words like that. This is as an example, right? But in fact, if I clear this, and so here you'll get all the connectiveness with the word ashab. Here's all the table, and so for example, yeah. So you can search some like that. So you can see word 1 and word 2, and you can select a particular word, for example, that are connected. For example, Anzal al-Kitab, right? So here's Anzal al-Kitab, which forms it has taken. The word form might change because it could be derivatives of the same root, but they are all these words that are connected are kind of shown here. So you can leverage this database to build second-order relationships and look for their recurrence and strength of recurrence. That's one way. We can eventually maybe make 3 words table, right? 3 words connectedness, or increase the distance between the words mentioned. Okay. One application of this that I was, kind of the roots really help us strategize our search in the Quran a bit better. So one application was developing memory maps for the Quran. Any questions before I go into that?
Yes, Dr. Muhammad, is this database, it's specific with 2 words with the same root or different root? Can you search with different roots? No?
Oh yeah, you can search with any roots in the Quran you want. Like this table is the complete Quran. Search this. To develop this table, it took my computer many months.
Yeah. This I see,
because of all the combinations that are possible.
So we can combine every 2 words in the Quran. So
yes.
even are not.
Yes, any 2 words you can search if there is a link.
Can you search? Yeah.
Yeah, you can search if there are links between them. If they are mentioned either adjacent to each other or like maybe close to each other with 1 word in between, for example, like a negation or a pronoun or something, they will be, that relationship will be added here. So you can look at here's, for example, Miskeen Ibn, and then there's Ibn al-Sabil. I mean, so you can think about applications for this. Ra wal Ba'sa, for example, right? So there are many applications like that that you can think about, but then we can also extend it to 3-word paradigm, right? So, but all the words are there. One of the things I wanted to go through is this memory maps for the memorization of Quran. So I tried to develop a traceability through Allah subhanahu wa ta'ala say, وَلَقَدْ يَسَّرْنَا الْقُرْآنَ لِلذِّكْرِ فَهَلْ مِن مُدَّكِرٍ. There are connectivity between the verses. And when you try to look at what are these connections, or how is the Quran facilitates memorization. So we look for these kind of linkages between verses in sequence particularly. And so a lot of times you find that there are words repeated across verses. Maybe they're derivatives of the same root, but they take different forms, but they have similar meanings or linked meaning. When I did this, I found that 4,077 verses of the original 6,236, or essentially 65% of these verses, have words that are linked by roots of the word. 65% of the verses, so that's a high percentage. So I developed this paper. There's a research paper that I presented at the Iman conference, and the table for this. I developed a Quran script with these roots highlighted in red. So you can, for example, look here for Allama الذي علم بالقلم علم الإنسان ما لم يعلم. Allama is highlighted in red because it's repeated across the verse or within the same verse. And then insan is repeated here between this verse and the next one, right? So you can kind of develop this as you focus on these trigger words, if you will. You can develop some memory maps that helps you in memorization of the Quran. There's an entire script available. Here it is, with all the surahs and all the verses of the Quran. So hopefully that will help facilitate a strategy in memorization of the Quran. All right, so now we move to a bit more AI-focused kind of discussion. So, in AI algorithms and data science, what we really want to focus on is data and algorithms, right? A lot of times, data, when you develop an algorithm and you develop data, and you don't want it locked in your hard drive, because really you want to share it with the world. You want the world to access that data. You want the world to exercise that algorithm, right? And so it takes a little bit of a platforming dimension to extend your algorithms, extend your data to a way that is more accessible, more searchable, more usable by the scientific community in general, right? So developing tables and databases is great, but how do you share those with the world? How do you extend that? For example, I tried this Windows desktop application. Great. It's a very useful tool, at least for those who are advanced enough to have a PC and be able to use. The reality of today's world is that majority of people use their phones for everything, right? So they don't use the desktops anymore or laptops as often. They use their phone for everything. And they asked about, I get a lot of questions, do you have a mobile application? I said, sorry, it's kind of not set up that way yet, right? So it's not, these programs are not developed for the mobile platform, for the web applications. But how do I extend this? So it's a question that I thought about a lot. How do I extend this database and the algorithms and the SQL queries, the functionality, features, including future scientific kind of algorithms for AI, deep learning, so that I can share, it can be exercised and can be shared with the rest of the world. It's a very key question. But not undermining the complexity of platforming. Making tools that are interoperable with today's complex ever-evolving tool set. It's a challenge on its own, right? And what you develop today, 5 years from now, will be irrelevant, right? So it's challenging, and I don't want to necessarily worry about that. My focus should be on data and algorithms, right? As someone who's interested in the Quran. And I want to let other tools like Matlab, Labview, Python, enable tools to worry about platforming, right? Access to databases, access to complex systems. I will cover a little bit of that today. But I want to share with you not only, so I want to have a few slides on platforming, just to give you a sense of what is possible with these tools. Many of you maybe know Matlab, but haven't used it enough, or are not familiar with this diverse kind of new functionality. Labview is a little bit less known, but equally valuable tool as Matlab. I developed the Ar-Raqim program with Labview. And then Python is obviously freely available form of Matlab, that, if you will, it's not exactly Matlab, it's a different language, but it has scientific tools and libraries, freely available libraries. But you have to know how to integrate which libraries, and how you have to search for these libraries, figure out the interface to how to integrate them. It's a bit more complex on integration piece, but the language itself is simple to use. However, Matlab offers that more comprehensive environment that is fully integrated. You add tool sets to it, and these tool sets gives you a huge amount of libraries or functions and functionality to exercise. A little bit about Matlab. Okay, so Matlab you can use to deploy algorithms anywhere from servers type devices that are, or all the way to cloud-based solutions, right? So very scalable. It gives you a very scalable environment. You can deploy Matlab in cloud environments like the Azure or AWS, Amazon Web Services, connected with data-centric kind of hubs like Hadoop, Spark, Cloudera, all of those there that enable you to deal with large data. You can use it to target particular GPUs for accelerated computations, etc. And I'm going to go through these very quickly. I'm not promoting necessarily I'm not a Matlab salesperson, but I am, a very active engineer that uses it, and I'm actually one of their technical advisors as well, but for MathWorks. But I will just give you an exposure of what it can do. So for data science particularly, how you can access and explore data, how you can process data, analyze data, develop algorithms, take these models and deploy them in real life web applications. All that can be enabled through the Matlab environment. At ease, you don't have to worry about that infrastructure and the platform and the interfaces and the technology behind the scenes. You don't have to worry. It's kind of simple interface to you. In 2-3 lines, you can develop that, access that data, and it will, things behind the scenes happen, in the platforming world to enable that interface. You can also develop Matlab. There's something called Matlab Production Server that allows you to turn an algorithm with some input and output function, input and output variables, into a web API. A web API meaning you can pass data to it and get data out of it through HTTP RESTful interface. So you can just do an HTTP call. So with one click, essentially, your algorithm now becomes whether it's as complex as deep learning model or as simple as X plus Y equals Z, right? That can become web enabled. You pass data into it, get data out of it through HTTP calls, RESTful API. Okay, with that, now you can deploy this algorithm on a, let's say, a cloud server that hosts MATLAB production server, and you can make calls to it. So now that algorithm and your database sits on a cloud server, ready to receive any HTTP call from a web application or a mobile device, and you can perform exercise that algorithm that queries data, that does the search, processes data, whatever it does, and gives you back the result. So this is a very versatile environment for development, especially when we, as Quran specialists, we want to worry about algorithms and data. We don't want to worry about the rest of the platform, right? Because most certainly we will get it wrong and we will have a buggy platform if we have to worry, if we have to get into the details of that, right? So we want to leave platforming to the experts and focus on the value added layer, which is our Quran and data and algorithms related to that. As a again, this is again how you deploy web apps. You can take a Matlab. You can also develop a user interface in Matlab as an application on your desktop and deploy it as a web, so it becomes available on any browser that you can. I don't know if you can see here as clearly, but once you develop like this Raqim Quran search, if I developed it in Matlab, I could have easily made it available as a web application. From a web browser, you can exercise all the buttons and do the queries and all of that. Kind of an afterthought. I wish I developed it in Matlab versus Labview, but it's okay. This is how you learn, right? Yeah, there are some. Yeah, finally, there are a bit about deploying algorithms. You can generate code automatically from Matlab to target any CPU, any GPU. Well, I mean, there are an array of selected GPUs, but you can essentially code generate your algorithms into C, into C++, automatic generation of code, as well as CUDA code for GPUs. All right, so that's platforming. Any questions so far? All right. Okay. I will get into the AI piece of it. So now, developing deep learning models with Matlab. Essentially, one thing that we should really focus on is that Matlab is, yes, a more recent platform for developing deep learning models and training and inference engines, etc., and exercising those engines. But we should know, one thing we should know about that, Matlab is also interoperable with all these other platforms. So you can have a model in TensorFlow or Python, which are both Python-based environments for deep learning. Those are a bit more famous. They're from Google and Facebook. And kind of Matlab was a little bit of a latecomer, but now is a leader in deep learning. And so there is this ability to import and export models from between Matlab and TensorFlow and PyTorch, etc. And not only you can import and export, you can also call TensorFlow from within Matlab. So you can run Python from within Matlab, or you can run Matlab from within Python. Similarly, with Labview interface, both are scientific tools. You can run Matlab from within Labview or run Labview from within Matlab. So there's a way to interface to all these tools that is easy to do and very convenient. Now, Matlab provides tools for developing these AI models. So for example, whether it's your inputs are images, there are many types of image processing deep learning models, as well as sequences like data series or or you can look at words and letters as sequences as well, like data series or time series. You can develop this. I'm going to show you quickly. This is the deep learning kind of tool set in Matlab. You can build any kind of connected, like if your input is images or sequence or letters, you can add any kind of convolution layers or sequence processing layers, activation layers. Here's normalization, kind of general tools, if you will, like pooling and combination, etc., and then output layers. So all kinds of layers, tools available. Each one of those boxes, if I click on it, I get a property node that I can customize its behavior. Like here, if I go to classification, or the input, how many inputs do you have? You can customize all these behaviors. So you can easily add, take a node, add it here, and kind of connect it here, connect it there, like that, right? So you can, and that's how you can sequence things. But the truth is that there are, so you can develop your own deep learning model, and you can train it. You can export and import, generate code for it, etc. In Matlab, in Matlab code, and then convert that to C code if you want to generate C code from it. So these tools are available. There are pre-trained models that Matlab provides, so you don't have to start from scratch. There are different types of nets that are already developed and analyzed. You can customize using this type of, when you open it, you can go to the network designer and customize each node or add nodes as needed. So you can start from something that's existing that works, and customize its inputs and outputs, change the inputs and outputs to meet your model needs, right? Or model design needs. Or you can leave it intact as is, only change the inputs and outputs, like already, just change inputs and outputs to meet what you want. So that's called transfer learning, right? That's how you transfer an existing model into a new application. I have leveraged one such model called long short-term memory network deep learning model. And the purpose of it was to recognize the expression style between Quran and Hadith. What's the difference between Quran and Hadith? So long short-term memory networks are designed for applications where the input has an ordered sequence of data, and where you want information from earlier sequence to be that may be important for information that follows, like in signals or text or time series data. Okay, so that's what they're used for. So when you want to do a prediction, like for example, if I said to you to be or not to be, immediately you follow it. Oh, that is the question, right? So there is some prediction of the next sequence given a partial or part of that sequence or sentence. So you can essentially train these models on the expression style or expression language that's used in sentences or phrases. So you have a training on particular sentences, and you classify these sentences as belonging to author A or author B, okay? And then you have a testing phase where you have presented with totally new sentences, haven't seen it before, and it will try to attempt to classifies those new sentences as author A or author B, right? So I was interested in using this to see if I can differentiate between the source of text in either Quran or Hadith. First, we have to convert Arabic text to data. And so we have all these letters. And for example, a verse like وَمِن شَرِّ حَاسِدٍ إِذَا حَسَدَ will be translated into zeros and ones in such orders, right? As a sequence of zeros and ones. And that's the input data that the deep learning model will try to work on, to try to develop a sense of what sequence of letters you've used, how you've expressed, the style of expression. It doesn't understand Arabic, right? It doesn't understand meanings of words, but it does understand zeros and ones, right? So, and we are going to, so I did this encoding, if you will, for the entire Quran, and for about 700 hadiths. I trained it on half of the data and tested the other half. And because of lack of time, I'm not going to go through this, but this is what I was just explaining in terms of LSTM networks and kind of what I've showed you. So when I trained it, this is kind of the progress of training. Matlab shows you how you're training the model and when how much accuracy you kind of improve your accuracy with time. If you have a GPU, it will run faster and maybe perform better up to, but I stopped it at 90% accuracy. And as you see here, the blue are the, so from, this is 3,000 verses. Those are my test data, which is half the Quran. The blue are all the verses, and the y-axis is the length, how many letters are in the verse. So we only have one verse that is very long in Surah Al-Baqarah. The rest are kind of medium, and most of it is short in its nature. In terms of length, obviously the longer the verse is, more letters, more specific it becomes. You have more words, more data to classify this better, right? If I give you a verse of the Quran like Mudhammatan, right? One word. The likelihood of error that you might classify this as hadith versus Quran is higher than a verse that has maybe 10 words in it, for example, right? So, so the blue are all the accurate classifications, which is a lot. So out of the 3,000 verses for testing, most of them were classified as Quran, except a very few that were classified as hadith, and those are the short ayahs, very short ayahs. So it's kind of difficult to, you don't have enough data, if you will. This is for the hadith. Unfortunately, I have very limited hadith, only 700, and I only used half for testing. So anyway, I got more wrong on the hadith than versus the Quran. But to remedy this step, I'm developing a database of the hadith from Sahih al-Bukhari, extracting out only what the Prophet said. In other words, his direct spoken words, without the kind of the introduction parts or words by other people who relate the hadith. So hopefully we'll complete this database, and it will have 7,600 roughly hadith in it, and we can use those for rerunning this experiment, inshallah. This is the accuracy kind of, it's actually not so bad. You know, we have, if you look, this is on the left is training accuracy or efficacy of training. On the right is the testing efficacy. And we have about 88% accuracy in terms of classifying hadith as hadith, Quran as Quran. You know, with some, there are some, if you know, so 2,967 ayahs were classified as Quran versus 318 were classified as hadith. And on the hadith, we have 407 hadiths that were classified as hadith versus 151 that were classified as Quran. So it's not bad in terms of performance, especially with limited hadith numbers. So hopefully by boosting the number of hadiths to roughly the 6,000, 7,000 level, we will get improved accuracy. All right. We're almost out of time, but I just want to finish with some thoughts on related to Maqasid. So essentially, as you saw, we have to start with when we develop. There are some a platform for Maqasid AI interpretation, we need some foundational layers to start with. So we need to have a Quran script as raw data, develop some additional metadata, derived data from it. We need to have express the verses in a grammar structure. So we need to develop syntactical analysis for the verses, for the ayahs, right? So develop a grammar structure that with which we can now understand more context of the verse, right? And then develop first order semantics, which are like synonyms, antonyms between the words, and limit the scope of words that you use for synonyms, antonyms to the vocabulary list used in the Quran, so that you don't have to expand into words outside of the Quran. If that's possible, I think that's the best way to do it, to develop these synonyms and antonyms. And then you develop second order semantics, which are related to, for example, a cause and an action and a cause, or going from a subject, verb, object to an outcome, for example, right? So this is, I call second order. Now we're moving from first order preliminary to second level, more complex kind of semantics. Or, for example, this is the reward or the result, and here is the action that led to that result. For example, you do good deeds, you get into the Jannah, right? So this is, your state is getting into the Jannah, but what it takes to do that is amanu wa amilu salihat, for example, and so once you develop these second order semantics, now you need to start doing classification groupings or clustering of nodes of these first order, second order semantics. Not only these groupings allow you to have nodes or clusters of information, but also now you need to link them together, right? Link them in the form of that linkage would express, for example, an action and a reward, or a state and a cause, or a verb and a subject, or a verb object, or some as we did in the, I showed you the example I did, is proximity in sentence structure or relationship, or emotional context. Put those, everything in an emotional context. And then use repetition and recurrence to have a strength value on that linkage, and then you present all that data to a deep learning AI model to try to retrieve information and classify, to classify information into a particular criteria, for example. Or so I think that those are kind of foundational layers that we have to go through in order to get to the level of interpreting Quran and looking at, so going from syntax to more semantics to relationships between them, and then develop the deep learning models on top of that to try to interpret how information is linked, and when you give it based on its training, you can give it some objectives and see or classification problems and see how it behaves at that. So that's all I had, and I appreciate your attention and time today. Any questions?
Yes, I wrote a question about the accuracy of in the Quran. How exactly we can check the accuracy of database? Because as you know, we have you had the problem with the Hamza, all the things. So how we can check this kind of accuracy?
Yeah, without the Hamza, all the different counting systems agree on the number of letters, etc. And as I mentioned, the words, there are only 37 words that are different by the spacing between two parts of a word. For example, ma lakum. Is there a space between ma and lakum? Awa aba'akum. Is there a space between awa and aba'akum? So, or do we count it as one word? So those are kind of more just space related, not really affecting context or meaning or pronunciation. And all we need to do is develop standards. We have a group of experts in Arabic language, in Sharia, that can get together and make determinations on what is the proper way to treat such, words. Those standards can be developed, and it's one of the objectives of the Quran Computing Institute to develop these standards. And then, this is only for riwayat Hafs an Asim, but there are other riwayas also that we have to treat and figure out the specifics related to those riwayat as well.
Thank you, Dr. So please, if you have any other question, go ahead.
Assalamu alaikum wa rahmatullah.
Wa alaikum assalam wa rahmatullah.
First of all, thank you very much, dear Doctor, for this useful lecture.
Thank you.
I actually enjoy hearing you in this lecture.
Thank you.
My question is very simple. Actually, in the lecture, you show us how we can use the AI to understand the Quran and the Hadith, and to have conclusions on Maqasid, for example. But my question is, what is the limit of AI? So, is there the limit of AI when we apply it on Quran, on Islam?
Absolutely. Yeah, absolutely. AI is not an artificial brain, right? It is only an algorithm. It allows us, it's a tool. We have the actual brains, right? So we need to be in control. And how we design it, it only does what you tell it to do, right? Based on your design for it. It's as idiot of technology as that, right? So, but it has some nice features, nice capability for processing large volume of data that we cannot ignore, right? So we need to leverage that ability to look at data with this multi-dimensional feature space, so many features. We as humans tend to be able to focus only on, a handful of things. Let's say maybe 5-6 things. If you can focus on 10 tasks at the same time, you're an amazing genius, right? So, but really, most of what we do is structure information. We tend to abstract information to take it to a higher level and simplify things in order to manage the diversity of data. However, AI can deal with all the details and complexity of data, right? So these networks are useful for that purpose. So let it do what it's best at, which is to manage diversity of data, diversity of features, exploring that space, classifying it into simpler output nodes, classifying as category, this data belongs to category A or B, All right, so we let it perform that, but what data we give it is essential in its performance, right? So the input, if you give it random data as input, you get random outputs, poor performance, right? There's a network, one of those networks in Matlab is called, it was trained on 1 million images. Okay, and now it misclassifies so frequently, that is because it's just such a wide diversity. You cannot really expect it to be specialized, right? So if you really want better performance, you focus on what data you give it as input. And then network layers, all of that, tuning them might affect, kind of slightly, but the output or performance. But generally, you'll get most of it is generally along the. For example, if I wanted to do recognition of manuscripts that are مخطوطات from Quran, the handwriting of the early manuscripts. you train it on those 28 letters, right? You only have 28 letters to train it on, but different handwriting styles, and then it can do optical character recognition. That, for example, 28 letters is not too difficult to train on. But if I wanna, so what data you give it is determining factor in the performance of the output. However, it's so frequent, as you saw even from data that I have here, there are some error, false positives, right? So it's not perfect. And yes, I can make it better by more training. If I had a GPU training done, it would take faster, but I can do more data volume. So you can improve the performance based on how you manage the model training and what the input data you give it, the design of the model, these flowcharts I showed you. You can tune them with particular characteristics to improve the outcome a little bit. But it is not a human brain, right? It cannot tell you the Maqasid al-Sharia because it doesn't understand the language, only based on how you train it and the structuring of information that you give it in this order, where you have syntactics and then semantics and then the synonyms, antonyms, the links and nodes and relationships and the strength of these links. All that data, when you present it to an AI model for training, it can abstract out features in this data space. And that those features is what it will leverage for classification, and it will help improve its classification accuracy. Hope that answers the question.
Thank you, Doctor, actually.
All right, great. Well, I'll be happy to take your any further questions in the email. I will certainly provide these slides for distribution on the maybe WhatsApp or email list. And please, we welcome you to join the Quran Computing Institute. And we welcome you to communicate with us either through email or through these social groups as well. Thank you very much.
I think we have here a question from Dr. Ildos.
Oh.
Yes, seems like it takes too much effort to prepare the data before you can feed into the model. What does it take to enable the machine understanding of natural language? In this case, Quranic Arabic, is there any easier way?
Yeah, this is what it took here. So it depends on what the model accepts as input, right? So you can train a model on 28 letters of Arabic text, or 29 with the Hamza, or if it's zeros and ones, if it expects zeros and ones, then you have to translate that data from Arabic letters into zeros and ones, right? In this case, this particular network that I used was expecting a sequence of input data in zeros and ones, right? If I actually have and that's across a dimension of 28 rows in this matrix. But if you can either train it on the 28 Unicode letters or translate those into zeros and ones and just leverage the existing models as is. But these networks are good at sequence of data.
I have a question related. Why specific Matlab? Maybe we can use another platform like Scilab or something like this.
You can.
Because I think it's more in accuracy, I think. And also,
Yeah, accuracy doesn't.
More performance. Yeah. Like Scilab.
Yeah, I don't think accuracy matters. Accuracy is a function of how you design it.
No, it's not. Yeah.
Yeah.
It's not a kind of accuracy. It's a kind of performance, I think.
Yeah. How you design it, what data you use, how much training you've done.
Yeah.
What data you've trained it on. That's what determines accuracy and performance. But you're welcome to use any tool that you like. The reason I like Matlab, again, for all these interoperability features that I highlighted, how you can deploy your algorithm so it becomes web-enabled, so that you can deploy it on in a web in the cloud, or to have mobile applications use that algorithm and model, right? It's this taking, I'm not only thinking about an algorithm in a closed space, I'm thinking about the entire user space, people who are out there on their mobiles, on the web, trying to search data, use the application, leverage information from it, so that it's not locked in my laptop or my desktop, right? And for those who are, so we need to integrate our tools that we develop into this modern space of technology. And while at the same time, we are not necessarily platform experts, and we don't want to waste our time on platform development. We want to focus on data and algorithms and leave platforming for others to do, right? We can leverage platforming that's in Matlab, but not necessarily have to worry about how we develop all this tool sets and interface and all of that, right? So I leave it to them to develop, and we just focus on data and algorithms and just focus on the science on that. But when we do develop it in the proper environment and tools, we can open up our algorithms and data to the world because of the interoperability features.
Thank you. Thank you so much. So no more questions?
Okay, great.
I think we're done, Dr. Muhammad.
Okay.
So
Appreciate
I think
the
thank you
invite.
very much. Yeah, thank you very much for
You're
this valuable lecture and great lecture. And may Allah subhanahu wa ta'ala reward you and make you among the Ahl al-Quran.
Thank you. Thank you.
Inshallah. Thank you so much.
Barakallahu fiik. Together.
Thank you.
Thank you.
Thank you. Appreciate it. Thanks for the invite.
See you, inshallah, in other events. Assalamu alaikum.
Wa alaikum assalam wa rahmatullahi wa barakatuh. Assalamu alaikum.